Chlorine dioxide is a chemical compound consisting of one chlorine and two oxygen atoms. Though chlorine dioxide is produced as a gas, it readily dissolves in water for disinfection purposes. It's worth noting that while chlorine dioxide has chlorine in its name, its chemistry and nature is radically different from that of chlorine, with 2.5 times the oxidizing capacity. This means the compound has the advantage of greater selectivity and lower chemical wastage as it does not react with harmless water impurities. The chemical works by attacking the structure of the bacteria to inactivate it. This form of oxidative attack ruptures the cell wall, as chlorine dioxide reacts with protein-based membrane components, making it simply impossible for bacteria to build up any resistance. Studies have also shown chlorine dioxide to be especially effective at inactivating viruses by the oxidization of the spike protein. In fact, chlorine dioxide is stated to be the most ideal disinfectant for treating viruses in water due to the way it interacts with the viruses to inactivate them. These gaseous properties also make chlorine dioxide highly effective at clearing biofilm slimes, which protect bacteria, allowing it to multiply. As a dissolved gas, chlorine dioxide easily permeates the structure of biofilms, inactivating the component cells and causing biofilm to break up and detach from pipework surfaces. On the other hand, biocides such as chlorine, unless dosed at high levels, will struggle to penetrate biofilm and will often be used up reacting with the surface layer, greatly reducing efficacy, and like bromine, becomes less effective as pH rises. Chlorine dioxide, however, is not pH sensitive, being biocidally active up to a pH of 10, and produces fewer byproducts and no trihalomethane contaminants, giving it a much better environmental profile than either chlorine or bromine. When compared to other oxidizing biocides, the advantages of chlorine dioxide are widely proven and documented. For example, ozone is a highly reactive biocide, but in many applications is purposefully neutralized via UV lamp due to its toxicity. Even in applications where neutralization is not required, the chemical still has a short half-life, making it only really effective at the point of application. This means there is the risk of insufficient downstream biocidal protection beyond the unit. By contrast, longevity is really where chlorine dioxide shines. This was shown during the 2020-2021 COVID lockdown in the UK, when data returned from a UCAS-accredited Legionella testing lab compared hotels conducting only outlet flushing against hotels with an Activ-Ox chlorine dioxide system installed. Low occupancy levels during lockdown meant greatly reduced water usage and stagnation. However, systems treated with Activ-Ox saw that the residual action of the chlorine dioxide present in the systems persisted for much longer periods. In the dosed premises, levels of Legionella were consistently and significantly lower than the premises not treated with Activ-Ox. Next up, hydrogen peroxide and silver, which is known to be an effective treatment for water systems but is required to be dosed at a much higher rate, with ongoing treatment at around the 10 to 20 ppm mark, as the chemical lacks selectivity and will react with impurities carried in the water, making it more wasteful. Hydrogen peroxide is also more corrosive, especially at these dosage levels. Chlorine dioxide, on the other hand, is effective for ongoing treatment at just 0.5 ppm due to its unique high selectivity, effectively killing microbes while reacting less with other water contaminants. Due to this, chlorine dioxide works as an excellent treatment for established and new systems, and ongoing treatment with chlorine dioxide will significantly improve control over biofilm in pipework which would otherwise harbour bacteria. Activ-Ox chlorine dioxide is used in many industrial and commercial applications. Food and beverage processors benefit from chlorine dioxide in the washing process, as the chemical is especially effective at reducing bacteria, including E. coli, Salmonella, and Campylobacter on food surfaces. It's also effective at controlling fungal spores to increase shelf life. Bottling plants use chlorine dioxide to disinfect bottles before filling and during neck rinses. And the chemical is also an excellent odor neutralizer and doesn't produce carcinogenic byproducts associated with other oxidizers and has minimal effect on taste. Poultry farms make use of chlorine dioxide for keeping drinker lines clear and chicks healthy. The mild taste is preferred by birds over other solutions which can leave the water bitter. Perhaps most importantly, as it is both Drinking Water Inspectorate and FDA approved, chlorine dioxide is a preferred treatment in Legionella control for office domestic water systems, including hotels and hospitals, reducing the risk of Legionnaire's disease contracted from spray aerosols out of showers, taps, and hoses. This is why chlorine dioxide is the ideal biocidal treatment, But to find out why Activ-Ox is the ideal way to produce chlorine dioxide, check out our Activ-Ox demonstration video.